Okay, now listen to me. These are two completely separate labs, okay? I don't want the diagrams, the force vectors to end up on the same graph. You treat these as like two completely separate identities, okay? Do not staple them together, nothing. This is one lab, this is another lab, completely separate, okay? Completely separate. So on the blue sheet, here's the first setup. Notice in big bold letters I said, show all the work for the calculations. So, scale 1, pick one. Let one scale be scale 1, let the other one be scale 2, I don't care. The force and the angle. What you have to decide is that which angle are you going to use? Are you going to measure this angle out here, or are you going to measure the angle with the vertical? You might make a sketch over here so that I know where that angle is, okay? This one doesn't have to be the scale, but you might make a sketch and go, hey, this is what we got. So you're going to have force one and the angle. You're going to calculate the vertical component and the horizontal component. You're basically trying to independently and experimentally verify that are the x components balancing each other out? Do the two vertical components add up to 9.8 newtons? That's what you're trying to see. Then, on number 3, this is on another sheet of paper. You're going to draw a free body diagram showing all the forces acting on the system. Do not do it using the hip to tail method. Include the scale. So, what that diagram is going to look like is something like this. It's going to look like a Y, but then you're going to draw in the x and y components. So on number 3, when you get done, this is what it should look like. So you're going to know these angles, you're going to know the hypotenuse, you would have calculated the x and y components, and you know that's going to be negative 9.8 newtons. So hopefully those two vertical components add up to 9.8, and hopefully your x components add up to 0. Then, on the second one, you're going to increase the angle. You do not have to draw a free body diagram for the second one. You just have to do the calculations. On the back side, there are 3 problems. Okay? These are all in equilibrium. So, if you look like on number 6, I've given you the 20 Newton scale, and I've given you an angle. You're trying to figure out is what's the reading on the second scale. So what you're trying to do on that one is you're trying to find the hypotenuse. Okay? You're trying to find the hypotenuse. But it's the same idea. What do your x components have to add up to? 0. Now, you're told that the suspended weight is 30 newtons. So on that one, this is 30 newtons. What do the two y components have to add up to? 30. So if one of them, say, is 17, what's the other one going to be? 13. Okay, makes sense. On the I-beam, this is a situation where it's symmetrical. So you can assume that everything is symmetrical on number 7. When you get to number 8 is what I just showed you. Okay? So on number 8, when you have the pulleys, boom, this, if you know what the tension is on the side, what weight it's suspending, then you also know what the hypotenuse is. Okay? All right, I'm done. You're on your own. So you've got 2 parts. Neither data collection takes very long. All right? It goes pretty fast. So, due tomorrow, stop you on camera.
Do you have a blue paper?
Yeah, here.